Today we talk about section 8.4 density and the center of mass. Density measures the amount of some quantity per unit size. To find the total quantity from density, we usually do two steps. First step is to divide the region into small pieces in such a way that the density is approximately constant on each piece. This is important. The density is approximately constant on each piece. The second step is to add the contributions of the pieces together. So now let's look at example 1. Example 1, a 6 feet long rod lies on the x-axis with its left end at x0. If the linear density of the rod is lambda x, is 1 plus x squared over 6 lb per feet. The question is to find the mass of the rod. So now let's draw a picture to illustrate this example. So suppose this is a 6 feet long rod with its left end at x0 and the right end at x6. So now we pick up small pieces along this rod. This is delta x. We know the linear density of the rod is given by lambda x. It's 1 plus x squared over 6 lb per feet. So now we can calculate the mass of this small piece. So the mass of a small piece is lambda x times delta x. So that is 1 plus x squared over 6 delta x. So now we add together the mass of all the small pieces. We get the mass of the rod is approximately equal sigma lambda x delta x. We add together the mass of all the small pieces. So this is sigma, lambda x delta x is this one. 1 plus x squared over 6 delta x. Next we let delta x goes to 0. We get the mass of the rod is equal to the integral from 0 to 6 lambda x dx. So this is the integral 0 to 6 lambda x is 1 plus x squared over 6 ds. So next we evaluate this definite integral. The antiderivative of this integrand is x plus s cubed over 18. Then x from 0 to 6. When x is 6, is 6 plus 6 cubed divided by 18. Then minus 0. So get this is 6 plus 12. This is equal to 18 lb. So we get the mass of the rod is 18 lb. 18. So this is example 1. So next we look at the center of mass. So we first review the formula for the center of mass. The center of mass, we use this notation as bar to denote the center of mass of an object lying along the x-axis between axis A and axis B is x bar is equal to the integral from A to B x delta x dx divided by the integral of delta x as from A to B, where delta x is the density. Density means mass per unit length of the object. So this is the center of mass formula. Next we look at an example. Find the center of mass of a 2-meter rod lying on the x-axis with its left end at the origin. If question A, the density is constant and the total mass is 5 kg. B, the density is delta x is 15 x squared kg per meter. First look at question A. The density is constant and the mass is 5 kg. We want to find the center of mass of a 2-meter rod. So since the density is constant along the road, we expect the balance point to be in the middle, that is x bar is 1. Next we will check this. We compute x bar. The density delta x, so we use the formula. Delta x is the density. So we have the density delta x is total mass divided by the length. Divided by length. So this is 5/2 kg per meter. The density is a constant. Then we get S bar, center of mass, is equal to moment divided by mass. So this is moment is 0 to 2 x delta x. Delta x is 5/2 dx. Mass is 5. So we get this is 5/2 times 1/5 times 0 to 2 x dx. So it's 1/2 times 1/2 x squared, x from 0 to 2. So this is get 1/2 times 1/2 times 2 squared minus 0. So this is 1 meter. So this is question A. Question A. So if the density is constant and the total mass is 5 kg, we get the center of mass is 1 meter. B. B is the density is this function delta x is 15x squared kg per meter. So next we use this formula to find the center of mass. To use this formula we need this integral, right, divided by this integral. So since more of the mass of the rod is closer to its right end, because the density is greatest there, we expect the center of mass to be in the right half of the rod, that is between axis 1 and axis 2. So we have total mass is equal to the integral from 0 to 2 delta x dx. This is 0 to 2, 15x squared dx. So this is 5x cubed, 0 to 2. So it's 5 times 2 cubed. So this is 40 kg. So next we use the formula to calculate the center of mass. X bar is 0 to 2 x delta x dx divided by total mass 40. So this is integral 0 to 2 x delta x is 15x squared dx divided by 40. So guys, this is 15 divided by 40 times 0 to 2 x cubed dx. So this is 15 over 14 times 1/4 x to power 4, 0 to 2. So this is 15 over 40 times 1/4 times 2 to power 4. As 0 is 0. Simplify, we get this is 1.5 meter. 1.5 meter. So get the center of mass of a 2 meter rod is 1.5 meter when the density is this function delta x is 15x squared kg per meter.